Oh, look, remember those times back when we were all, we hadn't graphed that periodic function yet? Simpler times. Anyhow, right now we're going to be looking at what we need to do in order to graph an equation, sorry, to create an equation from a graph or from a set of data. Okay? Here, you will be surprised to know that the temperature in Collingwood varies according to the season. If you had to approximate those curves with a type of curve, what are some candidates we could use to approximate those curves?
Like we like
Could you use a line?
you sign
Yeah, you could use a sine or cosine. That's the
sign
best
sign
answer.
sign got stressed
Fine, go straight to
hard.
the best answer. Would you like parabola? Would parabola work here to approximate that data?
Uh,
Ish, right?
not the
Ish.
not that not the
Not
first
great.
not January February.
No, it can't curl back up. That's parabola's problem. And it certainly doesn't repeat every how many months?
12.
12. Yeah. So the period here would be 12 months. And parabolas don't do that. You need to like define a new parabola every time. But then it would have like sharp corners at the bottom and a nice smooth corner at the top. And we would like a smooth corner at the bottom and a smooth not corner at the top. Not corners, smooth curves. So we can achieve that with periodic functions. Now, can you extract the amplitude, the period, the equation of the axis, even the phase shift from something like these pictures? How would you do it?
Uh, well, the equation, the axis looks like that.
Yeah.
We don't have the
Here we
y.
have two graphs. Let's be clear. One is the different highs of the month, and the others are the lows. We'll notice that we're just getting into the time of year where the lows are the lowest. And let's take a look here, and let's evaluate the lows, and we'll work on the lows here visually, and then we'll work on the highs next in a table of values that I've organized for you. So here we go. January and February seem to be our minimum. And would you agree that the minimum might be just a little bit below 9 there? Like
Yeah.
maybe negative 9.5? Okay, we could say that because if there's 2 points that are both the same, the low is probably in between them. Same idea here for July and August. Probably the end of July and the beginning of August would be the hottest temperatures. So that would give us our maximum and our minimums. Let's be simple and ignore that and just take our minimum to be minus 9 and our maximum to be 16. So minimum minus 9, max is 16. And visually it looks like somewhere in here, right, should be our like axis, maybe somewhere like that. Well, let's calculate what it is. The axis we calculate this way. We say, let's find the average of those two. So we're going to do 16 plus minus 9 and divide by 2. 16 plus minus 9 happens to be 7. And then do 7 divided by 2 is 3.5. Okay? So that would be our axis, like y equals 3.5. Right? And what's the amplitude? Well, it's however much the maximum rises above that or the minimum goes below that.
Oh, I did 12.5 and 13.
12.5?
I did it's maximum minus minimum, right? Divided by 2.
12.5? Yeah. So 16 minus 3.5. Like if you do the maximum minus the axis, you will get the amplitude.
Yeah.
So that would be 12 and a half. And then 9 plus negative 9 minus 3.5 would give you negative 12 and a half. So that's the negative amplitude. So our amplitude there was 12 and a half. Our y value, 12.5. The equation of the axis, y equals 3.5.
We'll have two different ones.
What's the
Right?
period here?
12 months.
12 months. Good. So we don't need to calculate. We don't need to look for patterns. We just know that our data has to fit that model, has to be 12 months. And sometimes you just know. Oftentimes I will just tell you in a word problem. The period is 12 months. And then the phase shift. Well, the phase shift is trickier to find. Let's talk visually how we would do it here. Would you like to model this with a cosine curve or a sine curve? Sine? I always choose sine myself. It's just my habit. Cosine would be maybe a little easier because I could just use a negative and then it would start at its minimum and go up. And I could use a negative a value, would be one strategy. I might need to shift it over just a little bit, shift it to the right like 1 month so that it's going down a little bit into January, February, and then start coming up. Okay?
What's the phase shift again?
That's kind of determines our initial position. It's the D value. How far to the left or right is it shifted? Okay? Here is one strategy to work visually to find the phase shift. Let's say I want a sine curve.
Yeah.
And I want to model this with sine. This is actually what I want to talk about. So here is my x-axis, my y-axis, y and x. Sine starts here, goes up, comes down. That's sine, right? At 360? Okay. Where does it start?
Yeah.
It starts at 0. What's it doing? It's going up. Okay. So you have to be aware of both factors. What is its value at its starting point and what is it doing? It's here rising and it starts at 0. So let's look on this function. Where is it rising and crossing the horizontal axis?
It's rising.
April. Good. It's about there. So what I needed to do was take my sine wave, which would have looked like this, something like that, right? And I need to shift it that way by 4. So I just shift the whole thing over by 4, and it will hit April at the right spot. Like April will get a rising temperature that's about the average temperature for the year.
Immediately goes up.
And notice how that should make intuitive sense. April has, on average, temperatures that are average for the year. It's kind of the middle of spring. They're not the coldest months and they're not the hottest months. They're right in the middle. And the temperature is increasing its temperature through April. The other option would be, and the incorrect answer would be over here, like end of October, beginning of November. Average temperatures for the year, but things are getting cooler. So we definitely want this one. So we're going to use +4 as our D. So there, we can take all of this and put it into a, period. If the period is 12 months, then we do 360 divided by 12, and that will give us 30 equals K.
So that's our D value.
That's our K value is 30. Our D value is +4.
Yeah.
So we would have this function. F of x, where F is the temperature, the low temperature of the year, and x is the month number, all right, would be equal to, we said 12.5 was the amount of temperature swing from the hottest month to the average month, or from the coldest month to the average month, multiplied by sine of bracket 30. That ensures we get a period of 12 months. Okay, 30 times x minus 4, because we calculated +4 for D, but D is a sign flipper. So put it in with the sign flipped. And then our C value was +3.5.
And how do you know that?
Oh, because of the equation of the axis.
Yeah.
So that would be the function that we could extract from that graph visually. Now, let's take a look here at what I got in Desmos for us. These are the high temperatures, all right? And they're based on this table. Let's go ahead and input the function we just created. F of x is equal to 12.5 multiplied by sine, bracket 30, bracket, x minus 4, end bracket, plus 3.5. There we go. Look at that. It looks really good, right?
How do we know which sign? That's
Oh, why sine?
Yeah.
Could we have used cosine?
Yeah.
Yeah, we could have used cosine.
But tan.
Doesn't cosine mean it's coming down that way?
Cosine will have a different D transformation, and that's the only change.
It's frozen up.
We don't get to see it up there, eh? Oh. There you go. I just have to shake the video for some reason. Okay, so see how nice that looks? That is the new function we just graphed. And those are the low temperatures. That would approximate the low temperatures over like many years. Okay. Now, let's take a look at the other example where we have the high temperatures organized for Collingwood in a table as month 1. So here, if you went through, you would find that the amplitude is about 12 for this table. The period is 12 months. The fact that those two numbers are the same is an accident. One is A and one is K. It just so happens we have about 24 degrees of shift in our high temperatures over the year. The horizontal axis for this one, well, oh, sorry, the amplitude, sorry, is 13, not 12, 13. Yeah. Let's get it from Desmos here. I had Desmos calculate these values, you can see, and it tells me that the A is like 13 and a half. We're going to use 13. Okay. The horizontal axis for this, go to the maximum and subtract the amplitude. It gives you 12. Notice if I take the minimum and I add the amplitude, I also get 12. So that checks out. So 12 equals Y. Now, I'll show you two ways to get the phase shift. The first one we already looked at was go ahead and find the month that's closest to the midpoint for sine and say I want to shift in that direction by that much. So I need to shift in the positive 4 direction, maybe 4 and a bit. Since April starts at like 10 degrees, so I'm going to go a little bit into April to get to 12 degrees, which is my horizontal axis. Okay. If I wanted to use cosine, let's use cosine. All right. Cosine starts at the maximum. Cosine starts at the maximum. So I would want to shift a cosine function by about 7.5. Okay. So let's see if I can put that in with cosine, and it would look like this. F of x is equal to the amplitude 13 cosine of still 15, because my period is 12 months, so that's, 30, not 15, because 360 divided by the period gives you k, and that's 30. So 30 multiplied by x minus 7.5, and the brackets, and then plus the horizontal axis 12. Let's go ahead and pump that into Desmos and just verify. G of x, oh, why? Let's go ahead and take a look. Because I know that I want to, cosine normally starts this way, right? Cosine starts at its maximum and goes down. It's the only way to go from its maximum, okay? But in this case, I only get to the maximum around 7.5,
Right.
like 7.5 months, somewhere in between there.
Yeah.
So I want to shift the maximum to the right 7.5 months.
True.
Is that because? Oh, you're not doing the first. You're looking at.
Yeah, so I'm taking this and applying a D transformation to move it over there so that the maximum falls between July and August. And let's take a look at what that looks like in Desmos. G of x is equal to 13 cosine. Oh, I didn't put equals. Equals 13 cosine. Still 30 because the k is still 30. X minus 7.5. Oh, look, it lines up nicely. Plus
Left to right 7.5.
12. There. And it's just a little bit out of Desmos's prediction, but it's pretty darn good. I hope you'll agree. Pretty darn close to what Desmos has. Yeah. Camden? Yeah, sure.
Oh, is it because they're both on the maximum, like 25 is the maximum?
Yeah. So here's the new maximum, right? It's 7.5. Cosine's going to have its maximum at this D value because that's where I shift the maximum to from the x-axis. Oh, yeah, with this one it's 13. With the highs, it was 13. With the lows, it was 12.5.
Oh, then minimum would be the 1.5. Like so.
Maybe, yeah, maybe.
Sine transformation.
Depends on how fine you want to be. Like, if you look, my prediction there is out from Desmos's by a little bit. Desmos has fancy decimals here, and it's calculated those to a high degree of accuracy. I have not bothered. I have gotten it close enough for rock and roll there. Okay. Now, let's go ahead and take a look at some more algebraic examples where we're not just going to be close enough for rock and roll, but, but before we do that, you okay? Yeah, okay. Let's verbalize what the amplitude means, the frequency, the phase shift. The amplitude here was related to how much the temperature changes over the year. The difference between the maximum temperature and the average, or the minimum temperature and the average, is the amplitude there. If you lived in some place near the equator where the temperature didn't change all year round, and it was moderated by some ocean currents, and it was always a balmy 28 degrees, then your amplitude would be 0. You'd have the same temperature all year. It would be like a wave that never waves. Okay. The frequency was the length of the year. We know 1 time around the sun is 1 time around the circle for our temperatures. And it's actually trigonometric triangle-like things that are moderating that. Yeah, people run sometimes. It's very, very distracting, I know. The phase shift is just getting the y-intercept right is kind of the phase shift. We could have, of course, put this in as like D is 0 and have April be 1 and used sine. And then it would have started at the midline and gone up for April. But I wanted my graph to start at January. January happened to be a descending temperature, so I wanted to move the function so that my starting position was correct. And the horizontal axis, just the average temperatures of the year. The amplitude is temperature difference. So let's take a look at this example. Let's find the equation of the function in terms of sine and cosine. And I will take you through some problems for finding this one and what we can do algebraically. I need to show you the algebraic method and how the algebraic method can go wrong so that you can get it to go right. Okay, let's go. First, how do I find the period? You look at it. Good answer. Where do you see it? From what points?
Looks like from what I can tell, so like the end is at the end is at 20 and it starts at I want to say -5 probably. Oh no, never mind. Sorry, I was looking at the other part. Yeah, -10.
Yeah. So this is 30x values. So the period equals 30. So what does k equal? K equals 360 divided by the period equals 12. So there's k. Cool. All right, now find for me the amplitude. Well, you could, but you don't really have to.
No, it's just 13 plus 3.
Well, this is here minus 3. Yeah, so 13 minus 3.
Yeah. 13.
So to find, you would do the maximum minus the minimum divided by 2 will give you the amplitude. So in this case, it's amplitude is given by this formula, max minus the min divided by 2. And that's 13 minus 3. So yeah, it's 13 plus 3. But I just want to go through that to say it's like that's not a sign flipper or something. It flips its sign in this formula. And so that gives us 8. So there's A equals 8. Now let's go ahead and find C. So how do you want to find C? With a formula or just looking at it?
That's just finding the equation.
Formula. Good. So you would find the average of the maximum and minimum is your formula. So maximum plus minimum divided by 2.
5.
So in that case, it's just 5. Yeah. So C equals max plus min divided by 2. So this is your formula for finding C. Okay. And that's going to be C equals 13 minus 3, or plus minus 3, is 10. 10 divided by 2. C equals 5. Okay. We've got the 3 easy ones to find, K, A, and C. And wouldn't you believe it, but D is the tricky one with these, to find it and to find it correctly. Huh? Why is it 5? Yeah. Here it is here visually. See how that looks like it makes sense?
The amplitude is the A value.
Yeah, the amplitude is the A value. Yeah. Now,
just whenever it crosses.
we've been asked to find one in terms of sine and cosine. Which one do you want to do first? The only thing that's going to be, they're going to have the same amplitude, the same frequency, and the same C value. Which one do you want to do first?
Sine, please.
Sine? Okay. All right. So let's go with sine. You chose the harder one first. Write out your function.
What you want, right?
Yeah. Okay. So I'm just going to remember these values. I just need a little more space. So I'm going to do this over here. Should have given you all a little more space on the handout. My apologies for cramping your writing. All right. So this function, f of x, is equal to 8, that's A, sine of 30. Wait, no, k was 12. 12 x
F1 is
minus d
Oh, yeah.
ma plus 5. Okay, that's our function without its d value. And we're going to find that d value. And we can do that this way. Okay, here's how we could do it. Let's work with this point. It's going to create an interesting contradiction, but I'll show you how to resolve the contradiction today. And if you have any friends in period 1, thank them, because they get to watch me fumble through this and remember that I sometimes forget how to do this. Right now, I remember how to do it. So if you learn best by watching me make mistakes, know that this is something like, that is hard. So what we get from this is f at 0 equals 1. F at 0 equals 1. That's true from this point. So let's put that in. 1 equals f at 0 equals 8 sine 12 times 0 minus d plus 5. Okay? Let's isolate that and resolve it algebraically.
So yeah, you just find a known point and over there.
Yeah, but watch. It's going to create some problems. I'll show you. 1, we're going to now get out our inverse operations pen. Bye for now, everyone. The video would be good to pick up at this point. Sure. Okay, great. Subtract 5 from both sides. So we're going to have, notice I'm peeling away layers of armor. I'm going to have 1 minus 5 is minus 4 on that side, is equal to 8 sine of 12 times 0 minus d. That's sine of negative 12d. Okay? And that 5 has been taken care of. All right?
Wait, why do you go to negative?
Where did
It's
you
12
put the F
times
on
negative
zero?
d. Oh.
Yeah, 12 times negative d is negative 12d.
Yeah,
Where
yeah.
did you put the
The 0?
Yeah.
Oh, f at 0 is, I put in 0 for x, see?
But now don't you just do like divide by 12 and then just divide everything by
No, you divide by 8 here.
Oh yeah, you would divide by
You
8.
divide by 8. And then you get 1 half, negative 1 half. Negative 1 half is equal to sine of negative 12d. Take the inverse sine of both sides. Bam. Sine inverse. Sine inverse of negative 1 half,
Oh.
negative 30 degrees. Oh, go ahead.
Square root 3 over 2? No.
No.
That's the
No.
No, I got
No.
No.
Here, let's go ahead and find a unit circle, and we'll look at it that way. You want to visualize your unit circle here and find it that way? Unit. Yeah. 210 is good, and there's another.
Oh yeah, it is 210. It is 210.
So let's look. So there it is there. Remember, it's the y values. For some reason, I can't move over far enough. It's annoying. There, 210 and 330. 210 and 330. So this is what your next line will look like. You want to remember that it could be both of them. 210 or 330 equals negative 12d. Okay? Solve each. Yeah. 210 equals negative 12d. d equals 210 over negative 12.
Negative 17.5.
17.5. Cool. Negative 17.5. All right. And then
negative 27.5.
And then the other one is 330 equals negative 12d. You divide both sides by negative 12. And then you can have, you said that was what?
Negative 27.5.
27.5, but it's negative.
Yeah.
Now, circle them both. But now we're going to use a bit of logic to figure out which one must be correct. When it goes past the y-axis, what's its behavior? Rising or falling?
It's falling. No,
Here it's falling.
Oh, there.
Yeah, here it's falling. So one of them will give me that point. like 330 or 270, one of them would give me that point. Is sine rising or falling at 270? Sorry, 210.
So
As we increase from 210,
180.
the angle, is sine rising or
I
falling?
think it's rising. Is it rising? Is that right?
Let's take a look at our unit circle.
I think it's wait.
I go from here. Oh, geez. Go back. No, go here. So I go from here, negative 1/2 to negative 1 over root 2 to negative 3 over 2 to negative 1. So sine is falling as it's going that way. Yeah,
Oh,
it's
yeah.
getting more and more negative.
It is? Oh,
Yeah.
It is. Oh, yeah, it is.
So that shows us that the 210 solution is the one we want.
Because it's higher?
Huh?
Wait, why do you want 210?
Because we want the one that has a falling sign as I progress the angle.
Sure.
Notice here the behavior. As I progress x, I'm falling.
Yes.
If I go from the other side of the unit circle,
Oh, because
like from 330,
it's
the sign is rising.
because 330
as we go around the corner.
Yeah.
Yeah.
So can you figure that out before you actually do like
Yeah.
the calc- okay.
You could only you could just calculate one of them. The other option is to figure out both of them, throw it both into Desmos, and see which one works. But of course, you can't do that on a test.
Yeah.
Wait, is it rising from the?
Yeah.
So
Looking for this.
So let's take a look at both of them and see what they look like when we use these, okay? So if I go over here, f of x is equal to, and we like this one, the one that came from 210, minus 17.5. Yeah, add 30 to it. Cool. F of x is equal to, we have 8 sine of 12 x minus 17.5. So this is x plus 17.5. And the bracket plus we had a y, a horizontal axis of 5. Okay, so we're going to compare f of x to g of x and just see what those two solutions, what difference they're going to make here. 8 sine of 12 x plus 27.5 plus 5. Okay, let's graph both of those and we'll compare.
But our answer is the f of x.
What's that? Oh, that's something else. Let's get a fresh Desmos here.
Dennis, is our answer the f of x one?
Huh?
Which was the proper answer?
Well, we're going to take a look at them both right now. So here's f of x we talked about. F of x equals 8 sine of bracket. We had a k of 30? No, k of 12. 12 x plus 27.5, right? Plus 5.
How do I know the
Oh,
17?
so there is plus 27.5 plus 5. That was g of x. And now let's graph f of x. Let's just change that to g of x. And now we're just going to duplicate that because we're only changing the d value. We can change this color to red and then say done. And then change this to f of x. And we had plus 17.5. There. Notice when I zoom in and show you this, they both have the correct y-intercept. But only one of them has the correct behavior, descending as it's crossing the y-axis. The other one, we got the right value, but we were ascending. And so that speaks to the things that are going on in the unit circle. As that angle goes down, past 210, sine goes down towards its minimum at 270. And then from 270, it's all uphill from there. This would be our transform 270 point right there.
How
Okay.
do you know what the 17.5 is? Like, how do you know where it is? Like,
Where's 17.5?
yeah, like how do you know where it is on here?
Well, that's 17.5. Let me graph y equals 5. Okay. And notice that we have here, there it is, 12 and a half,
Yeah.
27 and a half. But we have a plus there, so that's going to actually be over here at negative 2.5, negative 17.5. There it is right there.
Okay.
Because it's a sign flipper, you see. And the blue one we have over here at negative 27.5. So that's where they kind of show up. They're hard. That's why D is the trickiest one to find. It's hard to read from your periodic function, you kind of need to either look at where am I rising and crossing the horizontal axis, transform over that way. That's awkward here, but because this is at a fraction there, 12 and a half. So if I change this one to minus 12 and a half, that's also perfect. Just working visually there in Desmos. If I was in the morning when I did that visually, I said it looks to be about 13. I would have been wrong slightly, you see? Been wrong by that much. So that'll be working visually, but visually is hard. For D, visually is absolutely useful for A, K, and C, and you want to go through those. But to find D, you need algebraic. And you need to be thinking about the unit circle and what's happening to the value of sine at different points. And what two values will also give you a solution there, and which one is the correct one to use based on are you rising or are you falling? Rising or falling, yeah.
You can literally get the entire thing from just looking at it except for K, except for D.
Yeah.
So then, what about those?
Oh, okay. So it's 2:02. So if at this point you want to tune me out and start some of the practice examples there, go for it. I'm going to go ahead and find a cosine function for this as well by popular request. So here's my strategy for find a cosine one. It's going to have the same A, K, C, and D, but I know cosine starts at its maximum and then goes down. That's the only place it can go from the maximum. So a nice thing about that is there's no ambiguity. There's only one point that's a maximum.
Yeah.
Right? Here there were 2 points that have a value of 1 there, that one and that one. And I don't want this one to be over here. I want this one that has the behavior go down. But from the maximum, it's always go down. It's always go down. So I notice here I'm over at 20, but I would prefer that to be at 1. Or back here I'm at minus 10. So D equals 10. Or D equals minus 20. They're done.
Oh, like subtract it from the.
Yeah. Because a D of minus 20 is going to push it that way by 20.
Oh.
Okay?
Oh,
Or a D of 10 is going to subtract from it that way.
Oh.
It's usually to get it. Oh, that makes a lot of sense because cosine starts at its maximum, so you just go off what the maximum gives you.
You see where the maximum has been transformed to,
Yeah.
and then push it that way with a D transformation. That's a little easier, isn't it?
Yeah. it's so
Yeah.
Then how do you know which one it is?
Yeah. Huh?
How do you know which one it is? Either.
Either one. They're both identical. They're like coterminal angles of each other.
Periods.
Yeah, they're a period. They're a period apart. Yeah.
So
So
this
it
is
wouldn't matter if I said 8 or 10.
Yeah.
8 or 10.
It's like if
One is positive, one's negative.
So you have like this is gonna be really analogy.
Sorry,
So
negative.
you have a conveyor belt of bagels. They're all bagels, just one's at 1 second, one's at 2 seconds.
12x, we said minus 10, minus 20. X minus 20.
So there's more than one answer for D.
Yeah, answers may vary here.
But for sine, your answer's always going to be like 12 point whatever.
Yeah. This one was incorrect. This one was correct.
Yeah.
And that's how you resolve that ambiguity is what's its behavior as it's crossing the y-axis.
All right. So for the D, when doing cos, you don't need to do the equation stuff.
You still can.
You still can.
You still can. I'll do it. Here, I'll do it with the equation stuff. If I didn't know this already, I would say I would use the maximum. I can use the minimum too.
Yeah.
5, negative 3. Let's do that. Okay, so I'm just going to go over here to a blank page of pages. Boop, 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 boop. Where are my blank pages? There they are. Pages. Okay, so we have h of x is 8 cosine of we had period was 30, so this is 12 x minus d, I don't know it yet, plus 5. And I know this hits a minimum at the point 5, negative 3. Let's just check. 5, negative 3. So we can go there from there. Another advantage here is I can say, I know cosine hits its minimum at 180. I know that. So if I substitute in here, h at 5 equals minus 3, equals 8 cosine 12 x minus, 5 minus d. plus 5. Great, I can go ahead and solve that.
Right.
But what I would encourage you to do is know that cosine hits its minimum at 180. So all this equals 180.
All that equals.
That has to equal 180 for it to be hitting a minimum.
Yeah.
So find D. So let's go. 12 times 5 minus D equals 180. Divide both sides by 12 gives you 15. 5 minus D equals 15. D is negative 20.
So then for sine, when you substituted the when you
See how easy that was?
Yeah.
Yeah.
But when you're comparing sine,
Yeah.
why did you sub in 0.01? Like why did you sub in 5 negative 3?
Could have subbed in 5 negative 3.
Like you could have subbed in any point. Like
Any
10,
point. Any point.
or negative 10.
But I always need to be aware of the behavior of that point at that time.
Okay.
If I choose the maximum,
Yeah.
I can still use sine, and I will avoid the ambiguity. The ambiguity of is it rising or is it falling? Okay. So if I choose the maximum, I can still do that with sine.
Right.
With cosine, it was real easy because I just visually know it has to be moved over that way. With sine, I can still choose a maximum and calculate it. It avoids the ambiguity, and I'll get D correct. However, the example I'm going to show you tomorrow that we're going to look at together, Jamal wants to ride the Sharknado, a Ferris wheel that's 20 meters across. Its center is 7 meters above a shark tank, and so it goes through the pair of shark tanks in its revolution, and you get on it at like 2 meters above the shark tanks.
Yeah.
So wait, do I have that in there? No, this is missing some of the. Oh well, that's fine. It's missing some of the details, but I have it in the handout that we'll look at tomorrow. Anyway, so yeah, in that case, I'm not telling you when you're at the top. I'm only telling you at 0 you're 2 meters above. So you have like the point 0.02, and then I tell you you go down into the shark tanks. So there you have to use that awareness of there's going to be ambiguity, and I know how to solve the ambiguity. In the morning, I got this part wrong, solving for D, and I got a bit flustered, and I was like, just use the maximums. And then it's like, afterwards, I'm like, yeah, but there's some questions where you can't because you're not given a maximum or a minimum. So you have to be able to resolve these using ambiguous sign stuff. Okay, any questions from Team Learn at Home? Hit me up by email. Otherwise, bye.